Sellafield Limited as a technical advisor on GIS. Now, one of the things that we've recently adopted at Sellafield is the doing away with a certain acronym, and that acronym is actually GIS. The reason we've chosen to stop using that acronym is because people get confused by it and they don't really understand what we're talking about. And they have this false impression that GIS may solve all of their problems. But we've found that actually GIS can't solve all of their problems. What they really need to get on top of is data management. Okay, so we use the term location technology a bit more these days. And rather than looking at GIS, oh yeah, it's going to solve all your problems, we look at solutions to problems, and occasionally we might bring location into it to actually improve the way we share the information with the users. In this talk, I'm going to give a quick introduction to Sellafield. I'm not a nuclear engineer. My background is in IT and geography. So I'd recommend that anybody who's interested in finding out more about the work that Sellafield actually do, if you visit the website and go to the About Us section. And then I'm going to look at one specific application of GIS, which we've used to help us plan the long-term decommissioning project at Sellafield. And by long-term, I'm talking about the next 100 years of development at Sellafield. Okay, and that's called the lifetime plan. So it's our 100-year work program is termed the lifetime plan. And we've used GIS to help people understand that plan in much more detail. I've been with Sellafield for the last 3 years now, and it's given me a unique opportunity to look at how GIS technology can bring benefits to what is said to be the world's most complex nuclear license site. So this is Sellafield. It's located, for those that perhaps don't know, on the west coast of Cumbria, and occupies around about 4 square kilometres of land. And all of the operational things that you see in this picture sit within an area of 2.5 square kilometres. The site employs, on a daily basis, 8,000 staff members. So you've got every day, in one of 3 gates, 8,000 people arriving onto the site to go about their work. And then a further 3,000 are employed in the same place as me in Warrington, at an engineering design house. So some key facts about the site. There's currently 1,400 buildings on the site, but this is a changeable figure. So one day it might be 1,400, the next day there'll be a few extra buildings go up as decommissioning work takes place. So you might be thinking, well, how come buildings are going up if you're decommissioning the site? What's actually going on there? Well, Sellafield decommissioning project is unique in the fact that in order to take some of these buildings down, you have to put buildings up, you have to bring in robot technology in certain cases to access the buildings and take them down manually, well, not manually, robotically. So this is why the project extends over the next 100 years. In addition to the decommissioning work, there's also certain operational work that's also going on at Sellafield. Sellafield is no longer a nuclear power generation plant, but it's a nuclear reprocessing plant. So you've got this strange situation where you've got an operational nuclear plant as well as a nuclear plant that's also undergoing decommissioning. 200 of the buildings on the site are classed as nuclear facilities. 40 kilometres of road, 15k of rail, 110k of underground drains, 168k water, 48k high voltage cables, 30k steam, 21k of active effluent pipe work, and 14k of chemical distribution lines. All of that within 2.5 square kilometres is a lot of assets to manage. And that's where we're trying to bring in GIS, or sorry, location technology, to help us out with some of this work. Okay, so the challenge that I'm talking about today is relating to how we've used GIS to basically map our 100-year work programme. So we also use GIS in other areas as well, but this is the one area that seems to have attracted quite a bit of attention in the business. Around about 2005, those people involved in planning the site who work in strategy realised that their systems didn't actually provide people with a very good visual representation of what's going on over the 100 years. We had very sophisticated systems for cost planning and schedule planning and that sort of thing. And we had very sophisticated drawings helping engineers understand the wiring of the sites between the different plants. But the one thing that we weren't able to do is actually go and talk to our regulators and stakeholders, and also internally, about actually what's going to happen on site and when that's going to happen. So yeah, if you look at the bullet points, we needed the ability to show the spatial and the temporal development of the Sellafield site. The obvious technology for doing that was location technology, or GIS. The three main reasons for that. Number one is we wanted to be able to link in with our current planning databases. So we use a system called Primavera, which contains all of our planning information. We also wanted a system that would allow us to accurately map the buildings and the other assets across the site. So again, the obvious option there is location technology. And then the last one, we wanted a system that would allow us to show the year-on-year changes that are taking place at Sellafield. That was a bit of a difficult one, because my experience of GIS wasn't, is that it's not that easy to actually do temporal stuff with GIS, okay? Esri are coming round to it a bit more now, and in their latest release of ArcGIS 10, they actually have temporal as a component of the core product. So we're happy about that, because we no longer have to do that using a fairly expensive software extension. So what we found is GIS technology could give us all of the things we need. But like I said at the beginning, there's no point in bringing in a GIS until you've got your information right. So what we had at the outset was all of the buildings on the site we had in CAD, in AutoCAD drawings, and that's how they'd been set up during the design process. And we didn't have any spatial information to do with all of the new plants that are going to be going up in future years. So that was the bugbear for about a couple of years, because we had to basically digitize a lot of this information and go out to the business and actually understand where all of this new build might be taking place. In terms of cost and time, we've had 3 people deployed on this work at 50% of their time. We've purchased 3 ArcGIS desktop licenses, and we've worked for approximately 3 years on the project. This is pretty small fry, I know, compared to some of the other talkers you're going to listen to, but we feel that we've been able to achieve quite a lot with a little in this case. This one I'll come on to in a minute, but the upshot of doing a lot of this work is we've been able to create a central data repository which business now has access to. Okay, so this is one of our mapping outputs. It looks a bit of a maze to the uninitiated. The notes at the bottom of the page essentially describe to anyone who's using this information what it's all about. So it says there, building and asset phases symbolised using data developed by the strategy and programs team in support of the lifetime plan development. This is the site plan, and the coloured blocks that you can see on there represent the plants that exist on Sellafield site, and the different colours associated with those blocks represent the different phases that a nuclear plant goes through in its life. And they're listed down the side there. The brown patch areas represent the spoil deposits associated with doing decommissioning work. So if you bring down a building or you put up a building, essentially you've got to remove ground, and that earth has to be placed somewhere. So not only are we mapping the buildings, but we're mapping the ground remediation as well. And that's represented in the key just down at the bottom. Like any GIS, the beauty of it is you haven't just got a pretty picture, but you can actually drill into the information, and you can determine what the lifespan is of a given plant. So you can click on that building there, and you can see, okay, that building during 2010 is in commercial operations, and further down the line, 2040, it might be going into the decommissioning phase. What we can also do is the temporal bit as well. So what we can do is we can show the user a year-on-year display of the site going through time. So there you go, that's 2020. And you can see that now we get a more blue colouring of the site as the plants move into initial decommissioning and the various other phases throughout the life. That's 2040, and you can see now that the actual the spoil sites are growing in size. Okay, so we have that ability to look through time.